In the early 1960s, a sunny afternoon at Fair Park in Dallas looked like any other day in a booming American city. But just beneath the grass and the playground walls, the city was quietly preparing for the end of the world. Buried right next to where children played, workers installed massive 4-ton steel blast doors. They were the entrance to an underground fortress operated by hydraulic lifts. Dallas and the surrounding North Texas region were prime targets for Soviet bombers. The area was packed with critical defense contractors, aircraft manufacturing plants, and active missile batteries standing ready to intercept a nuclear strike. The city and the federal government split a $120,000 bill to construct the Dallas Civil Defense Emergency Operations Center. This bunker was stocked with its own water, electricity, and food, specifically to keep exactly 30 high-ranking local officials alive for up to 2 weeks. The air intake system utilized heavy demi anti-blast valves, designed to slam shut before a pressure wave could enter the shelter. The city acquired these as surplus from the Nevada test site, where the hardware had already undergone actual nuclear blast testing. If a 20-megaton bomb hit downtown Dallas 3 miles away, the mayor and a small team of officials could survive inside. This municipal site was the local anchor for a much larger network of hidden federal fortresses. While city officials had a reinforced basement, the federal government built its ultimate contingency plan about 40 miles away, well outside the primary blast zones of Dallas and Fort Worth, in the city of Denton. Completed in 1964, the Denton Federal Regional Center was a 2-story subterranean complex. It spanned 50,000 square feet and sat 58 feet below the surface. The structure was engineered to survive the thermal pulse and extreme overpressure of a 1-megaton nuclear bomb detonating just a single mile away. The first line of defense was a set of 13-ton steel blast doors, operated by hydraulics, that would seal the stairwells against the initial pressure wave. During a nuclear detonation, a ground-coupled shockwave travels through the soil like an earthquake, capable of shearing concrete. To solve this, engineers mounted the internal facility on massive shock springs, allowing it to flex independently of the rigid outer shell. Keeping the concrete intact and the people alive solved the physical problem of the explosion, but the facility also had to guarantee that its occupants could talk to whatever was left of the outside world. High-altitude nuclear bursts create an electromagnetic pulse, or EMP. This sudden burst of electromagnetic energy induces high currents that will instantly fry unshielded electronics. To protect the facility's radio and telecom equipment, the entire communications room was wrapped in copper. The floors, walls, ceilings, and even the doors were lined with the metal, and copper rods were driven deep into the earth to ground any induced electrical surge. Beyond communications, the bunker operated as a self-contained underground city. It featured decontamination showers, medical dormitories, and an industrial-grade kitchen capable of cooking 3 hot meals a day for hundreds of federal workers for a full month. The Denton facility existed to ensure continuity of government. It provided a secure, isolated environment where federal authorities could manage national recovery efforts, entirely insulated from the radioactive fallout above. While government officials had guaranteed spots and highly engineered subterranean fortresses, the survival plan for the general public looked very different. The Kennedy administration launched the National Fallout Shelter Survey to find existing structures that could hold crowds of civilians. Soon, everyday post offices, schools, and church basements were marked with these iconic black and yellow signs. These buildings were chosen because they offered Protection Factor 100. This meant the thickness of their walls, or the depth of their basements, would theoretically reduce the radiation exposure inside to 1/100th of the levels outside. But the survey ignored critical survivability metrics. These public spaces offered zero protection against a direct blast. They lacked dedicated air filtration systems to scrub out radioactive dust, and for sanitation, the government directive was often to use chairs with holes over a bucket. Instead of an industrial kitchen preparing hot meals for a month, civilians were expected to survive on rapidly degrading canned goods and drums of water packed into tight, poorly ventilated quarters. The federal bunker had an industrial kitchen. The public had crackers and a bucket. This stark contrast in infrastructure transformed public shelters into psychological placebos, designed more to prevent mass panic than to ensure civilian survival. Today, the intense paranoia of the Cold War has faded, and the physical spaces have adapted. In Denton, those 13-ton blast doors are permanently welded open. The once secret, impenetrable federal fortress now operates openly as the headquarters for FEMA Region 6. The facility's resilient infrastructure now supports responses to highly visible, naturally occurring disasters. When major floods, tornadoes, and hurricanes strike the region, this bunker becomes the central nervous system for federal aid. The technology built to exclude the public from a nuclear winter now coordinates their rescue from the Texas climate. A structure designed to survive the end of the world is finally being used to keep it running.